Assalamualaikum and good day to everyone. So in this video, I'm going to discuss the tutorial question for topic 5, especially for alcohols, aldehyde and ketones, and also the last one will be the carboxylic acid and its derivative. But I'm gonna divide the video based on the 3 subtopics just now. Okay, so for this video, I'm just going to cover for alcohol. Okay, all right. So I have asked student from S13, which is Akmal. Okay, Moma Akmal, to volunteer to prepare the answer for alcohols subtopic. Okay, so thank you Akmal for your answer. Okay, let's start. The question number 23, name the following alcohol according to the Iupac system and classify them as primary, secondary or tertiary alcohol. Okay, all right, so let's just check the answer. Okay, so the first one, as you can see, okay, so the step will be the based on the Iupac naming nomenclature. Okay, so we have to follow all the steps as what have stated in the Iupac. Okay, all right, so kita kena identify the longest and continuous chain and make sure that it consists of the functional group. Okay, and then the substituents, the lowest numbers possible, and then alphabetical order. Okay, all right, so for E, the name is 222 and then comma 2 dash di because we have 2 methyl group. Okay, and methyl, and then dash a 3 dash heptanol. So it's supposed to be heptanol because this is an alcohol. Okay, all right. Okay, and then the type the classification of the alcohol, it is a secondary alcohol. Okay, so let's look at B. So we have to identify the longest. So this is quite obvious that this chain will be the parent. Okay, so whatever it is, you have to check. Okay, so this will be 8. So going, and it also consists of the parent, the function group. And if we start from here and then going down 1, 2, 3, 4, 5, 6, we got 6 carbon only. What if we start from this side, from the right hand side? Okay, 1, 2, 3, 4, 5, 6, 7. You only got 7 carbons. So the longest, and it also contain the functional group, will be this straight chain. Okay, right. So that would be octanol. Okay, so the name, the full name will be 4-iso-propyl-6-methyl-4-octanol. Okay, all right. If you would like to name this isopropyl based on Iupac, because this is considered as complex substituent, okay, where you have bracket. Okay, you can also name this isopropyl based on Iupac style. Okay, so this would be called 1-methyl-ethyl at carbon number 4. Okay, 1-methyl-ethyl. It's just that you have to, in terms of alphabetical order, okay, in terms of alphabetical order, since it starts with M, 1-methyl-ethyl, so it should be at the back. Yeah, it should be in front also, because we have methyl and the other one is also methyl, 1-methyl-ethyl. So we have to compare in terms of the numbering. Okay, in terms of the numbering. So 1-methyl, 4-1-methyl ethyl, and then 6-methyl, and then 4-octanol. If you are going for that complex substituents, okay, for Iupac naming style. And then this is primary. Okay, identify the alcohol, the hydroxyl group. Is it primary? I don't think it's primary. It's tertiary. Okay, this is wrong. Okay, so it's tertiary. So identify the hydroxyl group. So it is here. And then you identify, classify the carbon that directly attached to the OH. So this carbon is attached to another, directly attached to another 3 carbons. So this carbon is tertiary. Therefore, the classification of the alcohol will be tertiary as well. Okay, so this will be tertiary lah. Okay, moving on. Next, the last one is known as 3-cyclobutyl, 3-cyclobutyl dash 5-methyl hexanol. Okay, very good. And then this is primary alcohol. Right. Okay, moving on. Number 24. The 2-methyl-2-butanol reacts readily with HCl at room temperature to produce 2-methyl-2-chlorobutane. Name the reaction and state the type of mechanism involved. So initially it is an alcohol. When it reacts with HCl, it produces this alkyl halide. That means the OH has been removed and the chlorine has been added. So this is substitution reaction, and to be specific, it is known as nucleophilic substitutions. Okay, but we have 2 types of nucleophilic substitution. So we have 1 and also 2. Okay, in order to assign whether it is SN1 or SN2, you have to identify the classification of the alcohol. Okay, so you have to classify the classification of these 2-methyl-2-butanol. So 2-methyl-2-butanol, if we were to draw this structure, okay, if we were to draw this structure, this is how it looks like. Okay, this is how it looks like. So this is 2-methyl-2-butanol. Is it 1, 2, 3, 4? Yes, butanol. And then carbon number 2, we have OH and also methyl. So this is how 2-methyl-2-butanol looks like. So identify, as you can see, identify the classification of the alcohol. So it is a tertiary alcohol. So once we know that it is tertiary alcohol, so automatically we would know the type of nucleophilic substitution, okay, for this tertiary alcohol. So it prefers SN1 reaction. Okay, it prefers SN1 reaction. So the answer would be, if the question is asking for, name the reaction and state the type of mechanism involved. All right, correct. Okay, let me just check with the. Okay, so it is nucleophilic substitution SN1. Okay, and state the type of mechanism involved. All right, so basically the OH will be replaced with Cl. So the reagent used is HCl. Okay, the reagent used is HCl. Right, that is correct. And number B. When 2,2-dimethyl-propanol reacts with thionyl chloride, white steamy fumes are liberated. Okay, identify the white steamy fumes. So these white steamy fumes is known as hydrogen chloride. Okay, it is hydrogen chloride. And then this is specifically for thionyl chloride. It will produce these steamy fumes that represent the hydrogen chloride. Okay, next, draw the structure of the product form. Okay, right. So, but first you have to to draw the starting material first, the starting compound first, the 2,2-dimethyl propanol, because from here, okay, we would want to know the type of reaction that this compound undergoes. Okay, all right. So when we draw this 2,2-dimethyl propanol, so this is how it looks like. This is 2,2-dimethyl propanol. Okay, all right. So let's just check 1, 2, 3. So this is the longest parent, or you can also go here. Okay, 1, 2, 3. So it is propanol, and at carbon number 2, we have 2 methyl group. So it is 2,2-dimethyl propanol. And then you identify, okay? You identify the classification of the alcohol. So this alcohol, so identify the OH group first. Okay, identify the location of the OH group. So this OH is attached to this carbon. So this carbon is only attached to one carbon sahaja. Okay, don't get confused with this group here. Okay, so you must focus on the functional group and then focus on the carbon that directly attached to the functional group. So this is the carbon involved. So this carbon is only attached to one carbon. So this alcohol is a primary alcohol. So since it is a primary alcohol, so it will proceed with SN2 reaction. It is still nucleophilic substitution, in which the OH will be replaced with Cl that is provided by SOCl, the thionyl chloride. Okay, so this OH will be replaced with chloride. Okay, it's just that it will proceed with SN2 reaction. So, what will be the product form? Sebab soalan tanya product kan, draw the structure of the product form. So, exactly as what we have earlier. Okay, the starting compound is just that the OH is now replaced with Cl. Okay, that will be your product form. Okay, so this is correct. Okay. Yes, correct. Okay, number 3. Explain why we do not treat 2,2-dimethyl propanol with HCl. Okay, right. So 2,2-dimethyl propanol is a primary alcohol, so it will proceed with SN2 mechanism. Hydroxyl group OH is a poor leaving group and requires an acid catalyst under reflux heat to convert it to a good leaving. Okay, so this is a good answer because OH is very poor leaving group. Maksudnya it's not easy to remove the OH. Okay, it's not as easy as compared to halogen. It is very attached to the molecule. Okay, so it is very difficult to remove the OH from the molecule. Therefore, it is a poor leaving group. So in order to push ataupun to force this OH to be removed from the group ataupun to be out, to be kicked off from the molecule, okay, we have to prepare the condition in such a way that it force, okay, dia menggalakkan pengeluaran the hydroxyl group. Okay, because so the reason is because of OH ataupun hydroxyl is a poor leaving group. Okay, so we cannot just simply use HCl. Okay, HCl we only have chlorine, one chlorine there, one halogen present. Okay, but if we use SOCl, if we use PCl5, PCl3, okay, we have a lot of Cl there. We have a lot of halogen, so this will create an environment that could to increase the rate of the removal of hydroxyl group, okay, from the molecule. Okay, so it's a poor leaving group. All right. Because dia primary alcohol, dia primary alcohol. Dia bukan macam tertiary alcohol. Tertiary alcohol, dia akan jadi carbocation. Because when it becomes carbocation, it's already unstable. Kalau dia dah unstable, dia boleh react dengan siapa-siapa saja. Okay, HCl lah. Maksudnya kalau ada satu klorin pun kat situ, halogen pun dia akan react with that halogen. Dia tak perlukan environment because dia itself is already unstable. Okay, but for primary alcohol, you kena push the living group to leave. Okay, to leave first. Dia, bukan push dia untuk leave. Dia akan attack kan? Dia akan attack from the opposite side. Sorry. Okay, it will attack. The Cl will attack to the opposite side of the opposite side of the hydroxyl group lah. Okay, SN2. Kan? Dia punya style yang ada 5 bonds tu. Okay, dekat transition state. Okay, so dia kena ada support lah sikit dekat situ. Alright. Okay, 25. Give the major elimination product when the following alcohol undergoes acid catalyzed dehydration. Okay, that means the removal of water, so it will produce, okay, this reaction will produce alkene as the product. Okay, all right, so it requires acid to catalyze this reaction, this dehydration reaction. That means hydrogen and OH will be removed from the molecule and finally form the double bond. Okay, so we have 4 compounds here, 2-methyl-3-pentanol, and so on. Okay, so first thing first is you have to draw the starting molecule first so that you could predict the location of the double bond form later on. Okay, all right, so we're going to start with A first. So this is 2-methyl-3-pentanol. Let's just check, is it the correct structure for 2-methyl-3-pentanol, is it? Yes. 1, 2, 3, 4, 5. Yes, we have 5 carbon there. And then at carbon number 2, we have 2-methyl. We have methyl group. At carbon number 3, we have OH group. So this is the correct structure of 2-methyl-3-pentanol. Okay, so this is the reagent used in this reaction, but you have to check in terms of the reagent and condition for this dehydration reaction. Okay, let's just very quickly check the lecture note on the dehydration process. Okay, all right, so we would need, we would use the sulfuric acid and it should be heated. Okay, and it should be heated. All right, should be heated. Okay, so you can only have this H2SO4, or you can also use either one lah, H3O plus atau H2SO4. Okay, all right, and then you need to have the heat. Let's see, the heat that would represent the heat. Okay, let's just check again. Ni so dia menggunakan H2SO4 sulfuric acid. Okay, all right, so let's just use H2SO4. Okay, and then we have heat there. Okay, so as you can see, the OH will definitely be removed. Okay, and not only that, the hydrogen, okay, the hydrogen that is attached to the adjacent carbon ataupun next to this carbon, it will also be removed. Okay, all right, so this would be the carbon yang memang akan terlibat for the removal of hydroxyl, but we also have to identify the adjacent carbon because that adjacent carbon will also be involved for the removal of hydrogen. Okay, all right, so we have 2 adjacent carbon there. Kebetulan ada dua. So kita kena consider for both lah. Okay. So here we have one hydrogen. This also, for this carbon here, we also have one hydrogen. So this is just a matter of preference. Okay, so which hydrogen will be chosen, will be prioritized to be removed. For this one, we have a rule that governs the removal of the hydrogen. So it is known as ZZEF. Okay, so based on ZZEF, they prefers to remove hydrogen from carbon that has more substituents lah, ataupun more substituted carbon. So between this one, apa nama tu, this carbon, and this carbon, which one is more substituted? So here we have two hydrogen there sebenarnya. Okay, alright. So you can, the tip is just refer to the number of hydrogen present for that particular carbon. So we only have one hydrogen for this one, or it is a tertiary carbon. And this one, this is secondary carbon, or it has two hydrogen, which is more than this one just now, the tertiary carbon just now. So of course, the double bond will prefers to form with the carbon yang has less hydrogen. Okay, that means this hydrogen and this OH, these two will be removed. And they mesti side sebelah carbon yang terlibat tu mesti adjacent ataupun next to the one that is directly attached to the functional group, to the hydroxyl group. Okay, alright. So when these two are removed, so it will form double bond between carbon number 2 and carbon number 3. So this will be the major product lah. Okay, alright. So since dia tanya major, is it? Dia tanya major ke? Major, give the major elimination lah. So kalau kat sini, dia akan minor elimination. Okay, sebab dia secondary dengan tertiary. Kalau primary, it is very unlikely lah. Okay, it prefers to form tertiary, of course, because of the stability. Okay, alright. So this is correct. This will namakan ke? Give the major for M. So give the major. So it's just you have to draw only. Okay, right. So this is correct. And then 2,3 dimethyl butanol. 1, 2, 3, 4. So it is butanol. At carbon number 2 we have OH, and at carbon number 2 and 3 we have methyl group. So we have 2 methyl groups. Okay, all right. So identify. So OH will be coming out. So this is actually, it has 3 hydrogen there. Okay, and then for this carbon, it has 1 hydrogen there. Okay, all right. So this is tertiary and this is primary carbon. So obviously the double bond will form here. Okay, between carbon number 2 and carbon number 3. So this one will be removed as water. Okay, so this one you replace it as H2SO4 and then heat. Okay, all right, so this is also correct. Next, 2-methyl-2-butanol. Seems like, oh, lain nama macam lebih kurang sama, okay? All right, so draw the 2-methyl-2-butanol. So this is the correct structure of 2-methyl-2-butanol. Okay, all right, so this one, again, you actually have 3 hydrogen there and it is a primary carbon. For this one, you have only 2 hydrogen. Okay, so this is more substituted compared to the primary carbon here. Okay, so based on CHM, it would prefer to form double bond between this carbon number 2 and carbon number 3. Okay, all right, so this is the one. Okay, good. Next, 2-methyl cyclohexanol. Okay, all right, again, we have 2 options. So one is, okay, with this one. Okay, so for this one, this is tertiary, this is secondary, like what Akmal has classified here. So for this tertiary carbon, it has only one hydrogen, so it will form double bond. It prefers to form double bond between the first and the second carbon. So this is first and this is the second carbon because it is a tertiary carbon. So the double bond will form here between number 1 and number 2. Okay, between number 1 and number 2. All right, correct. Yeah, so number 26. Alcohol with the molecular formula of C4H10O have 4 isomers. So this is the chemical formula given to us, and this is the info. Okay, so it is stated here that based on this chemical formula, it has 4 isomers. Okay, all right. So you have to show lah. Okay, all the 4 isomers later. So draw all. So like I said, draw all structural isomers, the 4 isomers just now, and arrange them in order of ease of dehydration with acid. Okay, so kesenangan to form double bond lah, because we know that the final product of dehydration will be alkene. Okay, so yang mana yang lebih prefers yang mana yang senang to form alkenes. Okay, right. So again, you have to consider the CHF. Okay, first thing first, draw and show all the 4 isomers that having ataupun satisfies this chemical formula. Okay, all right. So the first one will be all right. Dan antara 4 tu adalah 2-methyl 2-propanol. Okay, correct. So this is the structure of 2-methyl 2-propanol as long as it has C, 4 carbon, H, how many hydrogen just now? 10. And then 1 oxygen. Okay, all right. So this is another isomer, also known as 2-butanol. 2-methyl 2-propanol. So this is the structure, and this is 2-methyl 2-methyl-propanol also. So the correct structure again. And then last but not least, we have butanol. Okay, 1-butanol or butanol only. Okay, right. So these are the 4 isomers. And then soalan kedua dia adalah arrange them. Okay, arrange them in order of ease of dehydration with acid. So kita kena arrange lah yang mana yang lebih senang untuk undergo dehydration. Okay, lebih mudah to undergo dehydration. So the answer would be tertiary alcohol, and then this is secondary. Okay, how you identify the one that easily undergoes dehydration? Okay, kita identify the classification of alcohol lah. Okay, all right. OH. Let me just check. Okay, and then we compare with the dehydration. The more stable alkene as the major product. Okay, so the ease of dehydration follows the order of this one. Okay, so tertiary alcohol prefers to undergo ataupun easily undergoes dehydration, and then followed by secondary, and lastly is primary. Okay, because why? Kenapa kalau they prefer tertiary tu? That means during mechanism, okay, definitely there will be the formation of carbocation. So kalau ada formation of carbocation dalam mechanism, dia mesti akan prefer tertiary. Okay, so that's why we would go for tertiary alcohol and then secondary alcohol. Okay, so for 2-methyl 2-propanol and butanol, these two are primary alcohol, right? So these two are primary alcohol. So dia sama lah, dia punya ranking dia lebih kurang sama lah. Okay, kesusahan dia tu tetap sama sebab this carbon kan. So dia ada this bulky group and this carbon is only attached to one carbon, right? To this one. Same goes to this. Okay, so this carbon is only attached to this carbon. So sama juga kebulkian dia tu, apa nama tu, lain lah dia methyl group kan. This is ethyl group and this is like propyl group macam tu. Okay, so both also quite bulky, both also are primary alcohol. So kita tak letaklah this one. Okay, sebab dia kita consider sebagai primary alcohol. So yang paling senang would be tertiary alcohol. Okay, right, correct. Cuma yang ni lah. Okay, compare and contrast the behavior of this alcohol when it is treated. Name the product form when this alcohol treated with excess concentrated sulfuric acid. This is C. Kita tengah buat apa ni? Kalau kita buat A kan? Kita dah settle for A. Next, let's move on to B. Compare and contrast the behavior of this alcohol when it is treated with acidified potassium manganate. So we are talking about 4 alcohol just now. Okay, so when they are treated with all of this, what will happen? Ataupun you have to compare, okay, in terms of the behavior of this alcohol. Okay, all right. So best would be to have table lah. Okay, best would be to have table to show ataupun to distinguish ataupun to differentiate. Okay, so the ease ataupun apa nama tu, kebolehan dia to undergo reaction with the mentioned reagent just now. Okay, all right. So 2-methyl to propanol. This is just now 2-methyl tertiary alcohol just now. Okay, this tertiary alcohol. So when it reacts with concentrated HCl, which represent, zinc Cl2 in concentrated HCl. So this will be Lucas reagent. Okay, as we know, Lucas reagent is also the type of reaction that promotes SN1. Okay, the one that have carbocation in it. Okay, so that promotes the SN1. So SN1 prefers tertiary alcohol. So what will happen when this 2-methyl to propanol react with this Lucas reagent? So it will turn the solution cloudy immediately. Immediately ni you kena mention. Okay, you don't just simply solution turns to cloudy because we have apa nama, for tertiary and secondary, we also have both also will form cloudiness. It's just that one is immediately, the other one may take time. Okay, all right. So dia nak tanya produk. So what would the tanya produk kan? Okay, compare. Oh, dia tak tanya produk. Dia tanya observation lah, more on the observation. Okay, all right. For this is due to the formation of tertiary carbocation is rapidly and stable. Okay, right. For how about 2-butanol? Okay, let's go down the table. Okay, kita go through the table ke bawah lah, rather than so that we can compare. Kita boleh compare. So tertiary, secondary and primary. Apa dia punya observation? What's the differentiation between these three, this type of alcohol? So 2-butanol, like I said just now, it is a secondary alcohol. Okay, so cloudiness will also form, but it takes few minutes to be formed. So this is due to the formation of secondary carbocation, which is a bit slower. Okay, for the mechanism ataupun less preferred for SN1 reaction. Okay, all right. How about primary alcohol? This both butanol and 2-methyl-propanol is also primary alcohol. So it won't form cloudiness at all. Okay, same goes to butanol. It won't, no reaction form ataupun no cloudiness observed. Okay, that represent no reaction for this when it react with the glucose reagent. Okay, all right. Next, when this tertiary alcohol react with acidified potassium manganate, this is oxidation reaction. Okay, so when tertiary alcohol react with KMnO4, okay, there will be no reaction taking place, no reaction happening, no reaction occurring. Okay, all right, so that will be the answer because there's no oxidizable hydrogen, correct? Okay, so this is 2-methyl-propanol kan, as you can see, inilah ni 2-methyl-2-propanol. There's no carbon that is attached to this. There's no hydrogen that is directly attached to the carbon. So that hydrogen is what we call oxidizable hydrogen. So it's not present in this carbon atau in this molecule ataupun to be specific at this carbon. Okay, how about 2-butanol? So 2-butanol, the purple color will change to colorless. Okay, so you kena cakap decolorization of KMnO4. Please be specific. Okay, decolorization of KMnO4 from purple to colorless solution. So basically, the secondary alcohol will undergo oxidation to form ketone, right? Okay, how about primary alcohol? Again, kenapa 2-butanol can undergo oxidation? Because it has oxidizable hydrogen. Okay, 1, 2, 3, 4. So 2-butanol, so this is OH kan? So this carbon is also attached to one hydrogen. So this hydrogen can be oxidized. It can undergo oxidation and produce ketone. Okay, all right. So that's why they give positive results. So how about 2-methyl-propanol? Okay, and butanol. So this also will give positive result. Okay, again, you have to mention the purple color of KMnO4. Okay, will change to colorless ataupun decolorization of KMnO4. Okay, from purple to colorless. Okay, so methyl-propanol is primary alcohol. So it will be converted ataupun it will be oxidized to form carboxylic acid. Okay, it will form carboxylic acid. Same goes to butanol. Okay, you have to specify KMnO4 decolorization from purple to colorless. It will be oxidized to carboxylic acid. In this case, into butanoic acid. Okay, all right, very good. Betul, ini semua betul lah. Okay, right, betul. So, okay. Next, last one, alkaline iodic in Ki. So this is iodoform test. Okay, this test is very specific. It actually detects the methyl group. Okay, since this is for alcohol, dia ada tiga benda yang dia detect, CH3, okay, 2 hydrogen, and then 3 OH. The molecule need the carbon lah, to be specific, the carbon need to have this 3 in order to give positive results to iodoform test. Okay, so you kena check in terms of the structure, okay, especially for the carbon. Does the carbon contain these 3? So kena draw lah. Tapi dekat atas ni dah draw kan, boleh nampak lah. Okay, alright. Okay, cuba kita tengok. Okay, ada tak tiga-tiga tu? So this carbon yang attached pada OH, dia ada OH, dia ada hydrogen tak? Do we have hydrogen for this one? No, we don't have hydrogen for 2-methyl-2-propanol. So 2-methyl-2-propanol won't give positive result for iodoform test. Okay, dia ada OH, dia ada methyl, but it doesn't have the hydrogen. So tak boleh juga. Okay, how about 2-butanol? Kita kena check. Okay, so this carbon has OH and then it also have methyl group. Okay, it is also attached to methyl group and it is also consists of hydrogen. Okay, this hydrogen is attached to this carbon. So there are 4 bonds there. So 2-butanol will give positive results to iodoform test. So what happened is that the observation will be there will be a formation of yellow precipitate ataupun yellow solid form. Okay, so like what apa nama Akmal tunjukkan ni, so it need to have the hydrogen, the OH and the methyl at the same time. Then only it will give positive result to iodoform test. Next, 2-methyl propanol. Do we have apa nama tu? All it takes for iodoform test for in order to give positive result for iodoform test. Okay, so identify the carbon that is directly attached to OH. So we have OH, we do have hydrogen. Okay, so we have hydrogen attached to this carbon, but we don't have the methyl group. So this is not methyl group. Okay, this is not methyl group. So 2-methyl propanol will also give negative result ataupun will not give yellow solid, will not form yellow solid precipitate. How about butanol? Butanol also will not give positive result for iodoform test. Because this carbon, yes, it has hydrogen, it also have OH, but it doesn't attach to methyl. So this is not methyl, this is ethyl. Okay, all right, so that's why butanol also will give positive and negative result. Maksud no reaction will take place lah. Okay, no reaction will take place. So no reaction. Okay, there's no methyl group attached to this one. Yes, so only 2-butanol will give positive result for iodoform test. Okay. Yep. Cool. Right. Okay, now let's move on to the next question. Oh, ada lagi C. One of these alcohol is optically active. Okay, one of these alcohol is optically active. How do we know whether it is optically active or not? You have to check for each carbon. You have to check the carbon in all the carbon in each molecule, in each alcohol. Okay, whether dia chiral, whether it contains chiral carbon or not. Okay, kena check satu-satu lah. Okay, then draw the structure of this alcohol and identify its chiral carbon. So what will be the answer? You check each one of it. So in order to become chiral, it need to have 4 bonds. Okay, the carbon need to have 4 bonds, and then the carbon also must not be attached to the same group of atom ataupun to the same atoms. Itu syarat to become chiral. Okay, all right. So this is obviously not chiral. Okay, 2-methyl to propanol because it is attached to, if we are referring to this carbon. Okay, so the rest of the carbon will definitely not chiral because this carbon is attached to 3 hydrogen, so tak chiral dah. So this one attached kepada methyl. So dia dah the 3 group yang sama. No, it's not chiral. Okay, how about this one? Check balik. We have chiral carbon for this 2-butanol. Okay, right. So this one definitely not chiral lah. Okay, all right. So we have to check for this one. So this one, this carbon is attached to OH, and then the other one is methyl group, and then the other group will be ethyl group. Okay, and the last bond is attached to the hydrogen. So as you can see, all of them are different. So this carbon is considered as chiral. Okay, so we have 1 chiral carbon in 2-butanol. How about 2-methyl propanol? Okay, from the look of it, saya boleh nampak lah dia tak ada chiral carbon. Okay, alright, so this one bukan chiral, this is not chiral, not chiral. How about this one? Normally yang tengah-tengah tu you have to check whether it is chiral or not. So this is not chiral because it attached to one methyl group, the other methyl group. How about this one? This is also not chiral because we have two hydrogen attached to one carbon. Okay, butanol also will not be chiral because kebanyakannya dia primary dengan secondary kan. Primary dengan secondary. So dia ada dua hydrogen kat sini. Ini ada dua hydrogen. This one also have two hydrogen. This also has two hydrogen. This one has three hydrogen. Okay. Right. So the one that is optically active is only two butanol. Okay. All right. So this is 2-butanol has chiral carbon. So soalan tanya apa? Draw the structure of this alcohol and identify its chiral carbon. Okay. All right. So the structure of alcohol. So this is the structure of alcohol. So normally we will represent the chiral carbon ataupun chiral compound as using 3D structure. So this is how we would represent the compound. Okay, so focus on the chiral. So this is the carbon that is chiral. Okay, and then the rest you would need to compress everything so that the focus will be on the chiral carbon. Okay, just compress jadikan CH2, CH3. Okay, so it's better to write it this way rather than to combine everything like this, C2H5. Okay, I would not suggest you to transform this ethyl group into this. Don't do this. Okay, so instead you just compress them based on apa nama tu, berapa banyak carbon that we have in the group, rather than you compress based on carbon yang you compile everything based on number of carbon and hydrogen. Okay, so go for this one. And then yes, the rest are also correct. Okay. Alright. Then number 2 ada lagi soalan. Last, name the product form when this alcohol is treated with excess concentrated sulfuric acid. Okay, when we treat alcohol with concentrated sulfuric acid, this reaction is known as dehydration lah kan. Okay. Kalau reactnya H2S alcohol react with H2SO4, then it's not mentioned that it is heated. Tapi normally kita ada reaction kalau dengan sulfuric acid, it will be dehydration. Okay, which will produce the alkene. Yep, which will produce the alkene. So dia tanya apa? Nak mechanism ke? Okay, dia nak tanya. Dia tak tanya mechanism. Okay, dia tak tanya mechanism. So you can just ni lah, tunjuk sajalah. Product form. Dia nak product form. Okay, alright, identify. So this is 2-butanol just now kan? 2-butanol. So this is 2-butanol. So this is secondary lah kan? Secondary alcohol. So this OH will be removed. Okay, and then the hydrogen will also be removed. So kita ada dua option guys tu, whether to remove the hydrogen from this carbon ataupun from this carbon. Okay, alright. So the hydrogen, kalau based on CHM, the hydrogen will be removed from the carbon that is more substituted. Okay, ataupun carbon that has less hydrogen. So this one kita ada 3 hydrogen guys tu. But for this carbon, this is secondary, it only consists of 2 hydrogens sahaja. So OH will be removed and also hydrogen from the adjacent carbon, yang carbon number 3 lah. Okay, will also be removed. Okay, alright. Because this is secondary kan. So this is secondary lah, so dia akan remove lah. So kat mana? So this one lah. It prefers to form this. Okay, this is name the product form and this alcohol treated. Okay, jap. Tapi dia tak cakap pula in term of stereoisomerism kan. Okay, tak apa. Kita just focus on the question. So, dia akan produce this one. Okay. So, let's just assume this is the product form lah. Okay. So, dia akan form double bond here between this carbon. That one. Okay. So, sebenarnya, as you can see, when this reaction forms this as final product, okay, it can also form geometrical isomerism. Okay, it can also form geometrical isomerism. So geometrical isomerism, dia punya syarat dia punya rule would be the molecule need to consist of double bond. And then secondly, the carbon that has double bond that consists of double bond must not be attached. Each carbon must not be attached to the same group of atom. Okay, alright. So bila kita identify, dia satisfies the two rules of geometrical isomers. So these two butene. Okay, bila kita namakan dia 2-butene, and these 2-butene turns out to have geometrical isomerism. So dia ada trans and also cis. Okay, alright. So trans dengan cis, tapi between these two, dia ada preference pula. Dia akan prefer the trans. We don't learn this in we did not learn this in lecture, okay, but since Akmal dah tunjuk dekat sini, saya just inform lah, okay, just inform. So we have sebab dia form, bila dia form alkene, ada probability to have geometrical isomers. So we need to check on that. Okay, like this one kan, oh okay, alkene, okay, ada tak geometrical isomers for this alkene? Turns out ada. Okay, dia obeys the two rules tadi. So kita boleh buat dia in form of trans and also cis. But between this trans dengan cis, dia ada major and minor also. So the major would be the trans lah. The minor would be the cis. Okay, the minor would be the cis. So this is not preferable. Okay, this is not preferable. So ini option yang pertama kita lah. Yang kedua tadi yang kat sini kan, this is not preferable. So this is what we call stereoselective. Remember stereoisomerism related to optical isomerism and geometrical isomerism. Okay, so this is what we call stereoselective. Between trans and cis, dia ada pula preference. Dia prefers to form major. Dia prefers to form trans rather than to form cis. So cis will be the minor product, whereas trans will be the major product. Okay, this is due to steric hindrance lah. Steric hindrance. As you can see, kenapa cis is not preferable? Because cis, okay, both of the high molecular weight group will be located on the same side. So this would create repulsion there compared to trans. See, trans, they are opposite one another. So this would have less steric hindrance. That's why trans will be the major product and cis will be the minor product. Okay, but the most important thing is to predict the formation of the double bond for the alkene. Okay, that one because yang trans dengan cis tu you can identify later. Alright, so that is all for alcohol. So okay, so hope this video is helpful to you guys. Okay, and thank you.